All right. So we've got this question in the remainder theorem section. This actually, I didn't realise when we were talking about this previously, relates to our quadratic, division by a quadratic section. So we're given some information. When our polynomial is divided by z plus 1, the remainder is 8. So we're given this value here. I'm just zooming in so I can write a little bit nicer. So p, we're looking at when z equals p negative 1, we get this value of negative 8. And then we're given this other value here. And when divided by z minus 3, the remainder is 4. So p3 equals 4. All right, now that's actually just information, and the way the question was worded was why we went off on a tangent. Find the remainder when pz is divided by z minus 3 bracket z plus 1. So what we're looking at here is we're going to have pz all over z minus 3 and then z plus 1. Now this thing here at the bottom, our divisor in this one, so remember this, the divisor, is a quadratic. So it means that we're going to have, our result will be our quotient, and then we're going to have plus our remainder over our divisor. It's going to be over z minus 3, z plus 1. Now, the important bit with this is our remainder here, which shouldn't have been p, it should have been an r. This is actually going to be a linear factor because we're dividing by a quadratic. So this is the important part, is when you divide by a linear function, so one of these factors you get just a constant, but when we divide by a quadratic, we get a linear factor, which means that we're going to have a remainder which could be a z plus b, so z being our variable here. Now, this helps us because if we were to rewrite our polynomial, we can write pz equals our quotient times by our divisor, which is z minus 3, or z minus 3, z plus 1, and then it's going to be plus our remainder, which is az plus b. Now what we need to do is we're going to use these values we were given to calculate the remainders of these. So we had when p equals negative 1, we get this section here is going to be, we're going to have this whole, let me just copy and paste this. This might make it easier. So paste this, good. Let's sit that there. And then we're going to paste it again because we're going to need it for the next bit. All right, just getting a little bit ahead of myself. So I'm just putting that next bit in. We're looking at this line here, p negative 1. So that means every z here, we're going to change to negative 1. So I'll get rid of these and we're going to put in negative 1, and this here is 0, which means this whole thing is 0. Now plus a to the negative 1, because z was negative 1, plus b, and this whole thing, when z equaled negative 1, we had a remainder of negative 8. So that means that this whole thing has to equal negative 8. Now we've got the same thing here for 3. So I'm going to do this really quickly. So we're going to have 3. This cancels out, which means this whole thing cancels out. And we've got plus a times 3 plus b equals 4. Now we've got two simultaneous equations here. So we've got negative a plus b equals negative 8. And we've got 3a plus b equals 4. All right, so we just now need to sub this in and we get, so I'm just going to flip the signs on one of them. So let's just times this one by negative 1. And so we're going to have a take b equals 8, 3a plus b equals 4. If I put them together, I get 4a plus 0 equals 12a. a equals 3, which then means if a equals 3, I'm going to use this top equation. I'm going to have 3 take b equals 8, which means b equals 3 minus 8, which equals -5. All right, so I've got my two numbers now, b equals -5. All right, which means that when we divide, now we go back up to our equation up here, and I'm going to copy and paste this down. This was our equation when we divided by a quadratic. So let's just drag this down so we don't have to rewrite it. Copy that. We'll paste that down there. Okay, now we can swap out our a and our b, and we're going to have a equals 3 and b equals -5. B equals -5. So our remainder here, the remainder is actually now, it's not just a constant, we're going to have our remainder equals 3z minus 5, and that's actually a function. So it means now we've calculated this, we can actually work out our remainder for every value of this polynomial when divided by that quadratic. It's actually a function. So if we divided by that, it gives us a new function. All right, thanks.